Yo, what's up, calculus students? Last lesson on derivative rules, unit 2, and we're talking about the chain rule. Chain rule is kind of simple if you just practice it, just like all of our rules. It says that if you have a composition, not a product, but a composition, one function inside another function, you have like an outer and an inner function. What we know is that the derivative of a composition is just equal to the derivative of the composed function separately multiplied together. I like to say outsides and insides, use the O's and I's. Once you get enough understanding of outsides and insides, uh, you're good. So we look at a function, usually parentheses help us see an outer function versus an inner function. And for this first one, f, we could see we got this 3 parentheses to the fourth, like an outer function. And then we got this 2x cubed plus 1, an inner function. Now, we then take the derivative of both pieces. Now, what's the derivative of 3 parentheses to the fourth? You think about it as like 3x to the fourth. It's going to be 12x cubed, but it's 12 parentheses cubed. 2x cubed plus 1, its derivative is 6x squared. Don't forget to subtract 1. And then we multiply them together. If you'd like to go ahead and multiply, knowing that you can multiply things in any order, you could take the 6 and multiply by the 12 and get 72 if you wanted to. You could put the x squareds out in front. And then you have the parentheses cubed. Now, what goes in parentheses? We like to say Vegas. Whatever starts in the parentheses stays in the parentheses. The outer function was 3, 2x cubed plus 1 to the fourth, so 2x cubed plus 1. And now we plug in 1, and my slope of this function at 1 is 72 times 3 cubed. I'm not going to do the math. I'm just going to say it's 72 times 27. Okay? Cool. Hope that didn't freak you out. What if you don't see parentheses? We'll put them there. It's like, all right, we have an outer function that's the square root. I'm immediately saying, oh, a square root is a 1/2 power. An inner function, the 15 minus 6x. Let's take the derivative of our composed functions and multiply them together. Now we gotta be able to handle these negative 1/2 powers. You guys are not good at this, so we'll talk about it. Okay, you can multiply things in any order, so you can multiply the 1/2 and the negative 6, and I'm going to do that and get negative 3. I'm going to understand that a negative 1/2 power is the same as a positive 1/2 power in the denominator. It's like dividing. So I have this, and what starts in the parentheses stays in the parentheses like Vegas. We then plug in 1 to find the slope of g, the instant rate of change of g, which is negative 1. Now let's just remember the statement at x equals 1, because it is asking you to find the instantaneous rate of change. So it's like, I kind of do want you to keep this in your brain. We would say at x equals 1, g of x is decreasing. It's going down 1 y per x. This is exactly what it's doing. It's decreasing that quickly. When I, O, I. Derivative of O, derivative of I. Multiply in any order, combine constants. What starts in the parentheses stays in the parentheses. At 1, we get negative 20. H of x is decreasing negative 20 y's per x at x equals 1. Oh, this is a good one. O, 4 cosine parentheses, I. Pi x over 6. What the heck is the derivative of pi x over 6? Well, like, I'm going to write it. I'm not going to take the derivative of it, but I'm going to write it as pi over 6 times x. A lot of people get all worried about seeing pi and they think the derivative is going to be all funky, but it's like the derivative of pi over 6x is just pi over 6. The derivative of 4 cos, the slopes of cosine are negative sine. You have a 4 in front. Don't stress. Get that. Multiply in any order. The negative 4 and the pi over 6 can be combined to be negative 4 pi over 6, which is negative 2 pi over 3. Sine parentheses. What starts in the parentheses stays in the parentheses. Now I'm trying to find w prime at 4. I'll get negative 2 pi over 3 times the sine of 2 pi over 3. 4 pi over 6, 2 pi over 3. Sine of 2 pi over 3 is root 3 over 2. So my slope is negative 2 pi root 3 over 3 times 2, which is 6. And that actually cancels to be a 3. So let me just do it really quickly. Negative pi root 3 over 3. I gotta show you the work. Sorry. Negative 2 pi over 3 times root 3 over 2. Positive, we're in the second quadrant. Tall 30, 60, 90. And we get negative pi root 3 over 3. Okay. Very good question here. Sine cubed of x. I don't see the parentheses. Do they exist? Is this something that I need to use the power rule for? No. This can be written as 6 parentheses sine x cubed. We would not put the 6 inside. The cube is only cubing sine, so you don't put the 6 inside the parentheses. Instead, the 6 is part of the outside. Slopes of sine are cosine. That means my slope equation is going to be 18. I'm going to put the cos x in front of the parentheses squared. I'm going to keep it as parentheses squared. What starts in the parentheses stays in the parentheses. Just because I need to plug in pi over 4. So h prime at pi over 4 is going to be 18 times the cosine of pi over 4, which is root 2 over 2, times the sine of pi over 4 squared. That's root 2 over 2 squared. So I get 9 root 2 times 2/4, which is 1/2. I get 9 root 2 over 2. H is increasing by 9 root 2 over 2 y's per x at x equals pi over 4. All right, what about this one? Well, now the outside and the inside have kind of changed. Now the outside includes a trig function, and this is very important. The outside won't always be a power. Sometimes the outside can be a function. We'll see that more in the future. So the outside is the 6 sine, whose slopes are 6 cosine. X cubed slopes are 3x squared. I said the answer cannot be simplified. It's for a very good reason, because watch. The slope equation, therefore, is going to be, I'm going to move things around in any order that I want, 18 x squared cosine x cubed. And I'm going to plug in 2. I'm literally not going to do this. 18 times 4 times the cosine of 8. You do not know what the cosine of 8 is. Think of this as free response. Free response, you don't need to simplify. So we're good. Here's another one very similar to that, where the outside is the trig function. The inside is this x over 4, which is the same as 1/4 x. Don't forget. The slopes of negative 3 cosine is going to be, the slopes of cosine are negative sine. The slopes of negative cosine are positive sine. So I'm going to get positive 3 sine parentheses. The slopes of 1/4 x are 1/4. Write these in the order that I choose. 3/4 sine. What starts in the parentheses stays in the parentheses. Plug in 3 pi. I get 3/4 sine 3 pi over 4. The sine of 3 pi over 4 is positive root 2 over 2. So I get 3/4 times root 2 over 2, or I get 3 root 2 over 8. That is the slope of that at there. This is how quickly this is changing there. Super important. Okay. Tangent cubed. OI cube is outside. Tangent inside. 3 parentheses squared. Secant squared, which is secant x squared. Put these in whatever order you choose. Maybe you put things in just this order. 3 tangent x starts in the parentheses, so stays in the parentheses. Squared. Then secant x squared. Remember, secant squared is the same as secant x squared, which is important when we want to plug in values like 2 pi over 3. So how quickly is tangent cube changing in 2 pi over 3? Well, I got 3 times the tangent of 2 pi over 3. Let's think about 2 pi over 3. We got root 3 over 2 divided by a half, tall 30, 60, 90 triangle, which is root 3 squared. See, like, it's a lot easier, guys, to do this if you just can do it in your head. You don't have to copy down the unit circle. Like, if you can figure out the tangent, negative a half. Or if you can write your triangle really quickly and then do it, it's going to save you time. So the tangent of 2 pi over 3 is negative root 3. The secant is the reciprocal of cosine. The cosine of 2 pi over 3 is negative a half. So I have negative 2 after flipping it squared. Which means, let me move this so I don't get my face in the way. I have 3 times 3 times 4. So that's 12 times 3, 12, 24, 36. Look at that nice number. Look at that. Multiple rules. What do you mean multiple rules? Well, sometimes we got to use the product rule. And as part, like, sometimes we have to use the product rule and the quotient rule. And as part of the product rule or the quotient rule, one of the pieces derivatives involves a chain. This is tricky. Sometimes we will do the chain rule, but inside the chain, you have a product or a quotient. This is an example. It's like, these are very, very tricky ones. I'm not telling you to find it at a value. I'm just telling you to get the answer. This one especially, like something just like this shows up on the test because I want it simplified. And we're going to simplify some more in the future. We need to simplify more. So the outside of this is obviously the fourth, but the inside is a quotient. The outside's derivative is easy, but the inside's derivative involves the quotient rule. Slopes of the top times the bottom minus the slopes of the bottom times the top, all over the bottom squared. I'm going to go ahead and simplify the top while I'm here. Don't make mistakes like you guys did on your quiz with distribution of negatives. 2x squared minus x squared is positive x squared minus 2x. Okay. So here we go. I have x squared over x minus 1. Sorry, let's think about this. We have 4 parentheses cubed. That is the derivative of the outside. The inside, its derivative is is x squared minus 2x over x minus 1 squared. What starts in the parentheses stays in the parentheses. Cool. Now, watch what I can do, which is something you might be expected to do. X squared cubed is x to the 6th. Could even turn it into x to the 7th. x minus 1 cubed is x minus 1 cubed times x minus 1 squared. I get x minus 1 to the fifth. Are you expected to get here? Yeah, you have a problem on your test like that, where you're expected to simplify. So we use the chain rule, and inside the chain, we had a quotient rule. Now we go to this one. This is probably the one that most people will mess up on, because you're all in chain rule, you're all in chain rule, you're chain rule and chain rule and chain rule. And then you're like, okay, OI, and your O is what? X squared sine parentheses. And your I is 3x. Well, the problem is that your O is a product. Now, I think you could do it this way, provided you know what you're doing. But I don't know. I think I tried it a couple times and it's like gets really messy and it ends up not working anyways. So sometimes you got to understand the product rule or the quotient rule comes first. And then, as part of the derivative or the slopes of the second, you need to use the chain rule. Let me show you what I mean. L slopes are product rule. Slopes of the first times the second plus the slopes of the second. Okay, OI, this is for the second. O is sine parentheses, I is 3x. I's slopes are 3. Sine slopes are cosine. So I have 3 cosine, what starts in parentheses stays in parentheses, are the slopes of the second. Don't forget to multiply by the first. So just recalling product rule, slopes of the first, second. This entire thing is the slopes of the second, and there's the first. Okay. And you can leave it like that. Maybe you want to factor out something. We will be factoring more later in the lesson. I can factor out an x. I have 2 sine 3x plus 3x cos 3x. Okay. What if you have multiple sets of parentheses? For example, this is sine 3x squared minus pi cubed. Well, I have an outermost, I have a middle, and an inside. Two sets of parentheses require an O, an M, and an I, where we have an outside, a middle, and an inside. Now, it's no big deal provided you recognize that you have this OMI. So make sure you see it first. Then you can multiply things in any order, but let's be careful about the last step. So I'm going to put the 6x and the 3 together to give us 18x. I'm going to put the first sets of parentheses squared, and I'm going to put the second set of parentheses. Okay. What goes inside the square? Well, whatever started in this parentheses cubed goes inside this parentheses squared. What started in the cubed? All of that. Sine 3x squared minus pi goes in there. Cool? What about what goes inside the cosine? Whatever started inside the sine. What started inside the sine? 3x squared minus pi. That's an OMI. Here's another one. This is cosine 3x all to the 1/2 power. The O is the 1/2 power. The M is the cosine. The I is the 3x. O, 1/2 to the negative 1/2. M, negative sine. I, 3. Write it correctly. Let's combine the 1/2 and the 3. We're just multiplying stuff together. I get 3/2. Combine the negative with that. Negative 3/2. 1/2, negative 1/2 is like a positive 1/2. Maybe if we want to, I can show you how we don't have to have the 3/2 in the top divided by. You can just put the second piece as 1 over a 1/2, and then we have the final sign, and then we could smush it all together so it's just one nice fraction. We don't like having fractions inside of fractions in this class. we discourage that. So what goes inside the negative 1/2? What starts inside the 1/2? What started inside the 1/2 is the cosine 3x. What goes inside the sine parentheses? Whatever started inside the cosine parentheses. What started inside the cosine parentheses? The 3x. You want to smush it together. This is maybe something that would be asked of you of a test. On the test, since it's multiple choice, you do have to understand how to simplify. And that would be maybe the simplest slope equation. Okay. It's a long homework. But that's okay because we had class time to do it. That's what we're doing on Grandparents' Day is we're going to work on our homework. And now I don't feel that bad. I was about to be like, oof, this is long. This might take me like an hour and 15 minutes. Try to keep the homework videos around 50 minutes, I think is safe. Any more than 50 minutes, it's like, this is going to be tough for you guys. Okay. OMI. I rewrite it so I see two sets of parentheses. I have my O and my I. I can multiply these in any order. So I'm probably going to take the 3 pi, put them together, and then I'll have a big set of parentheses squared, and then I'll have a secant squared of a smaller set of parentheses. What's in the square? What starts in the cube? What starts in the cubed is tangent pi x. What's in the secant parentheses? What started in the tangent parentheses? What started in the tangent parentheses? Pi x. Cool. Rewriting this as secant 3x squared. OMI. Because I have two sets of parentheses, I have the composition of three things. I have a square, a secant, and a 3x. O. M. Now, this is important. Secant slopes are secant x tangent x. Secant x's slopes are secant x tangent x. Secant's parentheses slopes are not secant tangent parentheses. It's secant parentheses tangent parentheses. I think a lot of students make mistakes on that. They just write the tangent right next to the secant, but you need two sets of parentheses for these. Then we got the 3, and if we wanted to multiply the 2 and the 3 together, we got a 6. We got a big set of parentheses to the first power, and then we got two smaller sets of parentheses. What started in the parentheses stay in the parentheses, so we got these, whatever started here, which is this, secant 3x. We got what started in here is this, which is that. So I have to put 3x both here and there. Cool. Now, what about these? Yeah, classic. Like I keep throwing this at you because it ends up showing up on the AP exam every single year. You need to be ready for this. This is just the slope attached to a limit. If you say find the slope of 2 points infinitely close together, it's a tangent slope. It tells you the instantaneous rate of change. This question here, this limit question, gets translated into what is the slope of sine of 3x. It asks you to essentially just take the derivative. You have an O, you have an I. The slope of sine 3x is 3 cos 3x. That's your answer. It's like, well, I didn't do anything limit-wise. It's like, nope, you didn't. We didn't do anything limit-wise. We just said, these are the slopes of sine 3x. 3 cos 3x. What is this? What are the slopes of sine cubed x? That's what it is. It's like y2 minus y1 over x2 minus x1, which is an x distance. We'll call it h. We'll make the x distance 0. This is tangent slope. Slope of sine cubed x. Well, we have the cube on the outside. We have the sine on the inside. 3 squared cosine. That's the answer. 3 cosine x sine x squared. Really, really getting you guys here. We're only on page 3 of 6. Okay, let's go. Equations of the tangent lines. I need a y minus a y1 equals an m times an x minus x1. I don't think I'm even going to graph these because I don't have time. So, might as well get the y coordinates first. Plug into your original equation, plug in x, get a y. Cosine of 5 pi over 6 is negative root 3 over 2, so I have negative 3 root 3 over 2 as the y. That's my x, that's my y. How do I get an m? I need a slope. I got an o and an I. The o is 3 cosine. The I is 5x. I's derivative is 5. 3 cosine parentheses derivative is negative 3 sine parentheses. So the slope equation is negative 15 sine 5x. Slope at pi over 6 is negative 15 sine 5 pi over 6. Sine of 5 pi over 6 is positive a half, so I get negative 15 halves. So now I have my equation, y plus 3 root 3 over 2 equals negative 15 halves, x minus pi over 6. And if I had time to graph, I would. But I don't, so I'm not. All right, let's find a y. Negative 1, 3 minus 4 cubed, negative 1. Let's find an m. Well, I need a slope equation first to find the m. So I got parentheses cubed. I got 3 minus x squared. Three parentheses squared, negative 2x. Slope equation is negative 6x parentheses squared. What starts in the parentheses stays in the parentheses. The slope at 2 is negative 12 times negative 1 squared, which is positive 1. So the slope is negative 12. Y plus 1 equals m x minus 2. Great. Next. Yeah, the next set of questions are doozies. Ooh, this homework is a doozy. Who made this homework? I did. Okay. O is sine. I is pi over 6x. I'm writing it like that. I also need the y value. Might as well find the y value. The sine of 5 pi over 6 is a half. Boom, there's an x, there's a y. Let's find the m. So the slope equation is pi over 6 cosine pi x over 6. Plugging in 5, I got 5 pi over 6. The cosine of 5 pi over 6 is negative root 3 over 2. So I got pi over 6 times negative root 3 over 2, which is negative root 3 pi over 12. So here's my equation. Y minus a half equals negative root 3 pi over 12, x minus 5. H of negative 2, find the y value. 4 minus 6 is negative 2 plus 5 is 3. 3 cubed is 27. Next Mr. Messer. I cubed x squared plus 3x plus 5. I mean, if you're not a master at the chain rule by the end of this homework, well, then that stinks. Oh, this is a good one. It took us forever to get to this one. Gosh. My bad. What happens if you have multiple things? Oof, man, I wish I brought this up, but it's okay. If you have multiple things, you got to use a set of parentheses. Like the inside's derivative, 2x plus 3. So we have a 3 times 2x plus 3 times our parentheses squared, which is x squared plus 3x plus 5. If your inside has multiple things, use parentheses. How about that? What do I do? Should I distribute? Should I simplify? No, it's like we just got to plug in. I plug in -2, I get -4 plus 3, which is -1. So I'm going to get -3, and then I'm going to get 3 squared, which is 9. So I'm going to get -27. Let's just make sure. 4 minus 6 is -2 plus 5 is 3. All right, so yes, -27 is my slope. The y coordinate is 27. My cursor paused. Yep. -27, x plus 2. Okay, find the horizontal tangent locations. Oof. All right, at least there's only 3 problems, but these are doozies. And then we get into table problems, and then we finish off with more table problems. All right, so those won't take forever. These are doozies because we're trying to find out when our slopes are 0. All next unit is just slopes equaling 0, knowing like we're going to do more analysis of our slope equations, focusing on when our slopes are 0. So that's a little like, hey, this is going to happen. Now, we got another situation where product rule is going to come first. And as part of the product rule, we have the chain rule. Okay, so product rule first. Slopes of the first times the second plus slopes of the second require you to use the chain rule. Slopes of the second are 6 parentheses to the fifth times 2x. I'm going to write the slopes of the second as 12x parentheses to the fifth. What starts in the parentheses stays in the parentheses. That's the slopes of the second. Don't forget to multiply by the first. If you'd like to simplify from there, we do it. Now, we somehow have to figure out when these slopes equal 0. And the problem is we got this plus. We don't like sums equaling 0. We like products equaling 0. So what do we like to do to get products? We like to take sums and factor them to turn into products. Now, many of you probably can't see it, but I'm going to give you a little hint here. Let's just replace this parentheses, x squared minus 4, with something like a y. And if I wrote this out and said, could you factor this? I think you guys could. You guys would say, I need 2x and 5y's is the greatest common factor that I could pull out of that and that. What do I have left is 1y from the first piece, and then I got 6x squareds left from the second piece. We just factored this right here, just in a different form. If y equals x squared minus 4, well, then you know that my factored form is 2x, x squared minus 4 to the fifth. And then here, this is x squared minus 4 plus 6x squared. Okay, I got 2x, x squared minus 4 to the fifth, and then I have 7x squared minus 4. When does this equal 0? Well, when do all of our pieces equal 0? That's what we're going to find out. So when does 2x equal 0? X equals 0. There's 1. When does x squared minus 4 equal 0? X equals positive 2, x equals negative 2. There's 2 more. 1 to 7 x squared minus 4 equals 0. Well, maybe we have to set up and solve an equation. 7x squared minus 4 equals 0. 7x squared equals 4, or let's just go straight to x squared equals 4 sevenths. X equals plus or minus the square root of 4 sevenths, or 2 over root 7, or 2 root 7 over 7 if you want to rationalize. Yeah! That was fun. I have so much space for the next problem. So there's 1, 2, 3, 4, 5. I mean, I gotta look at it. I gotta look at it. X squared times x squared minus 4 to the 6th. I'm going to have to zoom out. So this is the back thing. Bam! 5 zeros. We got -2. We got +2. We got 0. We got plus or minus square root of 4 sevenths. And there it is right there. Minus, plus or minus. And then after that, there's same thing here. Product rule, then chain rule. Slopes of the first times the second, plus the slopes of the second, O and I, parentheses the fourth, x squared minus 3, 4 parentheses cubed, 2x, 8x parentheses cubed is the slopes of the second times the first. Factor. I'm like listening to a tour right now, so I'm not talking because I'm like, what are they saying? Plus or minus root 3, plus or minus root 1/3. Yeah, so like, they'll let you. You're going to talk. Yeah, root 1/3, which is root 3 over 3. Like, listen, I don't want to do this, but I'm going to do it. We got a product rule, and within the product rule, we have 2 sets of chains. This will be fun. So here's a product, but I got an O and I for the first one. I got an O and I for the second one. Okay. So slopes of the first 2 x plus 1. If you want help, just like put whatever starts in the parentheses. Slopes of the first times the second, plus slopes of the second times the first. Okay. I'm going to say this is 2 y z cubed plus 6 z squared y squared. Ugh. But you see that? Like, I'm going to say x plus 1 is y. So I have y1, y squared. I'm going to say 2x minus 3 is z. And then let's factor. Oh, I finished this before class. 2y z squared can be factored, leaving us with 1z from this, and then 3y from this. Both z's are gone, 1y is gone, 2 turns. Okay. So I got 2y z squared z plus 3y. Okay. What does that equal? 0. 2 x plus 1, 2x minus 3 squared. This turns into 3x plus, oh, I thought it was going to be better than this. Darn it. Because the 3's cancel and you just get 5x, so you really just get a 0. So I have 0, 3 halves, and -1. I'm going to graph that and be disappointed. It's supposed to be a 5th power, which means like there should be like 4. You would expect like 4 kind of turns, but I think the problem is you won't have that because of the multiplicity of things. Name. Look at that. -1, 0, 1.5. That's actually pretty nice to see. Like it's a 5th power. We know polynomials, we know the end behavior. But here it's one of those where we shallow out and we keep going up. This is like a good problem for the future. If I ask you to analyze the function, we'd have to understand that my function is going to flatten out, but then keep increasing. And we're going to do that the next unit, kind of really become like human graphing calculators. So that's fun. Okay. Table problems. Important to remember that this is not a product. So these are like the notational derivatives. This is not a product. This is an outside and an inside. This is a composition. I would say the outside is 3f parentheses. The inside is g of x. Or a lot of people make mistakes and they say OMI, and it's actually fine. You could do that. So you have 3f parentheses, then you have g parentheses, then you have x. The problem is you don't need that because whenever you just have x on the inside, its derivative is just 1. So it's like this is not going to change things. So I can write it as g of x, or if you want to write OMI, it's fine. If you're not comfortable that g of x's derivative is just g of x's derivative, g slopes are g slopes. 3f has slopes of 3f slopes. Like remember that 3 is not going to change things. It's just a constant. So I'm going to write the slope of 3f of g and say it's 3f slopes parentheses g slopes at x. And again, if you did OMI, it works out the same way. It's just not necessary because you just have you have g of x, and this 1 isn't going to change anything. Okay, what starts in the parentheses stays in the parentheses, and this is where it gets fun here, because if I ask you what's h prime of 3, you have to do 3f prime of g of 3 times g prime of 3. This is where we don't do products. It's a composition. We have to find one piece to find the other piece. G of 3 is 4, so we have 3. F prime, g of 3 is 4. So it turns into f prime of 4. And if my cursor starts working, that would be great. So this is 4. G prime of 3 I can find is -2. F prime of 4 I see is -4. So I have 3 times -4 times -2. So that's 3 times 8, which is 24. Cool? Again, you could OMI it if you're not comfortable. But after you've done it a couple times, you realize like the M and the I are not necessary because I's derivative is just going to be 1. So J prime is 2G prime parentheses times F prime of X. Again, it's like slopes. What started in the parentheses stays in the parentheses. What started in the G was the F of X. And now we work inside out composition. It's nice to have a nice data. 2G prime of F of 3 is what I'm trying to find, times F prime of 3. F of 3 from the table is 2. I don't know why my computer's got so slow. F prime of 3 is -3. G prime of 2 is -1. So 2 times -1 times -3. So that's going to be 6. Look at that. K prime is going to be 4x F prime of X squared. Plugging in 2, 8 times F prime of 4. F prime of 4 is -4. So I get -32. This is good. So it's not composing F and G. Here it's like F with something else. This is a good one to do. Again, you could OMI it if you want to, but it's not going to make any difference. You're going to get the same result. 2 F of X times F's slopes, plugging in 2. F of 2 is 4. F prime of 2 is -2. -16. Okay. Here, I'd rewrite this as g of x to the 1/2. You might be like, oh, I have 2 sets of parentheses, but the innermost function is x, whose derivative is just 1. So we really don't have to worry about it. So OI, in the future, you guys will not be showing O and I because you have done it enough that you're going to be like, let's not waste our time here. But like, let's get the technique down first before we then be like, okay, I got it. All right, so I have 1/2 root g of x times g prime of x. You can move the g prime of x to the top if you want. All right, so g of 3 is 4. That's nice. So I have 1/2 times the square root of 4 is 2. G prime of 3 I forgot to grab. G prime of 3 is -2. So I'm going to end up with -1/2. Oh, what do we got here? A product rule first with a chain on the innermost, or chain on the second piece. So I got the slopes of the first times the second, plus the slopes of the second, which is f prime of 2x times 2. So 2f prime, what starts in the parentheses stays in the parentheses, times the first, plugging in 2. I have f of 4 plus 2f prime of 4 times 2. Careful, that turns into a 4, but that stays as a 2. F of 4 is 3. F prime of 4 is negative 4. Cool. Just more practice, only extracting the information. Let's see how like the inside outside kind of works here. OI, 3F, G, 3F slopes, 3F prime, G prime of X. You don't need an OMI, but the next one we do need an OMI because the derivative of the 2x is not just 1. The derivative of the 2x is 2. So that's important. So here we go. H prime equals 3 F prime, what starts in the parentheses stays in the parentheses, times G prime of X at 1. I should be better with my notation. H prime of 1. So G of 1. G of 1 is 1, 2, 3, 4. I think my cursor's slow because this homework is so long. Unbelievable. Like, honestly, I almost want to just like close this off and open it back up. Slope of G at 1 is 1. I don't like that. Whatever. Slope of F at 4. 1, 2, 3, 4. Slope of that line segment is 2, up 2 over 1. So this is 6. Here's an OMI. G of F of 2x, because 2x's derivative is 2. F slopes, G slopes. This is important that we recognize we do need an OMI here. We got G slopes of F of 2x. We got F slopes of 2x, and then we have an extra 2. So at 2, it becomes F of 4, F prime of 4, 2. F of 4, 1, 2, 3, 4 is 1, 2, 3. So I get G prime of 3. F prime of 4 is 2. We got another 2. G prime of 3, 1, 2, 3. The slope of this line segment is down 1, 2, 3 over 1, negative 3. That's a good question. Negative 12. Last two. My cursor's so slow right now. G parentheses x squared. Slopes of G, slopes of G, slopes of x squared, 2x. Z's slopes are going to be 2x times G's slopes of, what starts in the parentheses stays in the parentheses. Z's slope at negative 2 is going to be negative 4 times G's slopes at 4. G's slopes at 4. 1, 2, 3, 4 is that line that has a slope of negative 3. So negative 4 times negative 3, positive 12. Oh, gosh, what is that? R? And then last one. You might think it's an OMI. It's not, because the innermost piece is X, whose slopes are 1, so it's not going to make any difference. If you want to OMI it, go right ahead. If you want to OMI it, fine. OMI. It's not going to make a difference because this value being 1 does not change what happens. So that's just an interesting thing to play around with if you're unsure. So I have 3 g of x squared times g prime of x. At 3, 1, 2, 3, 1, 2, 2 and negative 3. Times negative 9 is negative 36. We did it! How long did that take? Not long enough. That was long enough. With the 30 minutes of working in class, I think that was good practice. The chain rule, sometimes thought of as students' hardest rule, but I think you got enough practice to handle it here. All right, I'll see you out there. Last lesson, we got a review day, then we got a test coming up. Peace. 55 minutes, not bad.